Whereas my last animatronic heart design was an attempt at creating something accessible and easy to build, this design is something a little bit more complicated, really just an all-out effort to try and make as realistic as possible animatronic heart. So whereas the original design just had one simple DC motor, this design actually features 3 servo motors, 2 of which control the expansion and contraction in the main heart chambers, and another one of which at the top just follows the motion of the other 2. These are controlled by an Arduino micro and a PCA 9685 16-channel servo driver board, and within the code it actually uses a step function with a sine wave interval and a set value interval to drive the heart with a natural slow expansion and quick contraction, and the speed of this cycle is dictated by the potentiometer. If you're interested in hearing more about that, I talk more about it on my development video. So as for the 3D printing, like the original design, there's no real particular requirements to do with layer height or anything like that. All of the structural and mechanical components print fine without any supports, and a resolution of around 0.2mm is more than fine enough, just as long as you can be reasonably confident that your components will be strong enough. The only parts which did require some supports were the shell components that go on the outside. The only other complication with the 3D printing would be the fact that the base is comprised of 2 separate parts. It is totally possible to print it as one part, but it's much easier if you just print the 2 halves, screw them together and put a little bit of glue in there as well. On mine I use a soldering iron to weld the 2 sides of the base together, and I can't advise that because it probably isn't good for you. So once you've got everything printed, you should be ready to assemble. So as with all of these projects, there'll be reference images coming up on screen as well as in the download package, so if you're unsure about anything you can check those, and if you're still unsure, I've got an instructable where I have all the text instructions written up really thoroughly, if that's helpful to you as well. So once you have the 2 halves of the base together, you want to start by inserting all 3 servos into the base. Quick note on the servos: this design was originally designed for MG90S Tower Pro micro servos, but I was concerned that they wouldn't be strong enough to actuate the silicone skin. As I found out later, the silicone skin is a lot easier to move than I originally thought, so although I haven't tested it with the MG90S servos, I think it'd probably work fine. In my design I'm using Corona DS843MG servos, which are much stronger than Tower Pro servos as well as being more compact, but they'll fit into the exact same slot without any trouble. So starting with the bottom pair of servos, you want to firstly feed the wires through the slots in the base component, and to do that you might need to remove the plastic connector piece on the end of the wire. You screw in the servo with some 10mm M2 screws facing in opposite directions, and if you're using the Corona servos you will need to use the small plastic adapter which comes with it, which will allow you to screw the M2 screws in. The top servo is a little bit trickier. You're going to have to remove the base of the servo where the wire protrudes from in order to fit the servo into its place, and then once it's in there you can screw the bottom of the servo back in. Also note that the design only has room for 1 screw, which is the one towards the centre of the base, and that's just because the pivot on the top component would interfere with it otherwise. If your print came out anything like mine, the servo should be more than tight enough in its space and you shouldn't have to worry about it coming loose. The next step is to construct the arms. So using a servo horn which has been cut down to only 2 holes, attach 2 long link components, as they're called in the files, on the furthest hole from the centre and screw it in. You want to take an opposing pair of arm components and screw the long links to them on the flat sides. This will be a good time to check the images to make sure that everything goes together right, and be sure to leave it loose enough so that it can move freely. You need to make 2 of these sub-assemblies and screw them to the base using 10mm M3 screws in the big hole on each arm. You then need to construct the linkage for the top servo, so using a 2-sided servo horn, again cut down to leave only 2 holes per side, attach a short link on the outermost holes and screw upwards through the bottom, again leaving it loose enough to move freely, and using some 4mm M2 screws. Another 2 of these 4mm M2 screws go into the short links the opposite way to connect to the rocker component later on. You can also attach the rocker component to the top of the base with a 20mm M3 screw. Now you need to prepare the driver board. Because of the space restrictions within this design, there wasn't enough space for the normal terminal connection block which the servo driver boards come with, so you'll have to desolder that and solder on some wires into those holes. You need to attach it on the base, and there's a few different ways to do that. You could use M3 screws in the left side, although it'll be quite a tight fit through the little brass holes because they're a funny size, or alternatively you could use M2 screws with a bolt on the end. On the right side you want to use M2 screws of around 12mm long and screw up through the bottom of the base, through the board and into the micro standoff component, which is going to hold the Arduino micro later on. You could also plug in the servos at this stage with reference to the images, which will show you which is which. You then need to assemble the back plate, so the potentiometer and DC input can be screwed into the holes on the back. Depending on what potentiometer you're using, you might need to use a washer, as I did. I also had to use some needle nose pliers to tighten it up properly. Not that it's that critical that it's tight. The DC input should have the positive and negative wires from the servo driver board soldered onto the positive and negative terminals. The potentiometer needs to have 2 positive and 2 negative wires soldered on, and 1 wire for the signal pin, which is in the middle. I used jumper cables with a female end and stripped the other end for soldering, which made it easy to attach to the Arduino and the driver board. Then you want to attach the back plate to the back of the base, taking care to ensure the wires you soldered don't get taffled. The DC input should go on the right side, and the wires for the top servo should tuck securely between the DC input and the servo itself. You can then secure this backplate with 3 20mm M3 screws. You then need to program the microcontroller. So this Arduino, as I mentioned, uses a step function with a sine wave interval and a set value interval to drive the heart with a natural slow expansion and quick contraction. And the speed of this cycle is dictated by the potentiometer. Upload this code to the Arduino micro, and notice there's a different version depending on which servos you're using, because for some reason the MG90Ss were backwards as compared to the Corona servos. I think it's then a good idea to wire everything up on a breadboard using the circuit diagram provided, just so you can get an idea of how it works before it all goes into the model, because it's really compact and it would be hard to troubleshoot from that point. So just wire everything up and make sure that it works as intended. When you're happy that all the servos are moved in as they should be, slow the motion down to its minimum and unplug the power at the exact moment that all the servos are still after the quick contraction. The bottom servos should now be in their contracted position, so take this opportunity to attach the servo horns for the bottom pair of servos at such an angle that the arms are almost together, close to being touching. This will be quite fiddly. The top servo will be in its most counterclockwise rotated position at this point in time, so attach the servo horn in such a way as to allow the rocker component to be in its most counterclockwise rotated position. Realistically, you're probably going to have to experiment with turning the power on and off and use a bit of trial and error to get the ideal position. Then the last step is to wire the microcontroller. I have a little insulating plate that you can attach to the Arduino micro using some tiny little M1 screws, or alternatively you can just use some electrical tape. I was probably getting a bit carried away there. And then you can use some more M1 screws to attach the micro to the standoff component on the top of the servo driver board. Look again at the circuit diagram to make sure everything's wired up correctly, and remember that in this design the Arduino micro is upside down. Now if, like me, you're just using jumper wires for the Arduino, you're going to need to take off the black connectors for the SDA and SCL wires just so that they can bend down and be out of the way of the moving parts. It's probably a good idea to put some tape over the bare connectors, or maybe just some shrink fit tubing or something like that, and then you should be able to tuck all the wires away underneath the Arduino, between the Arduino itself and the servo driver board. And now, fingers crossed, you should find that everything works as intended. All of the side panels can be just screwed on with some M2 by 6mm screws. Notice that there's some different panels for the back where there's a little cutaway for the back panel, whereas the ones on the front are a little bit fuller. You can also put on the top panel by just clipping it into position and securing that with some M2 screws as well. In the final thing, this mechanism uses a silicone heart jacket, but in my other video I have a tutorial showing you how to make the infinitely cheaper plush fabric jacket. So if the silicone casting is not something you're into, you can use the fabric jacket, and then if you do want to do this silicone jacket, I'm going to release that video separately because there's quite a lot I have to say about it that can't fit all into this one video. So I hope that you'll come back and have a look at that one when it comes out. Thank you to everyone who watched this video, and thank you to all my subscribers, and a particular thank you to my patrons. They are Captain Awesome, Olasander, Aaron Haley, Aaron Nance, Adam Salmi, Alexander Koksharov, Andrea Gambacorta, Andrew Pusey, Armin Unk, Brian Seipert, Kaya Hoffman Silva Bueno, Christopher LaRoche, Daryl Barney, David Churchman, David Gentry, Elvind Hansen, Eric Klopp, Eric Farrow, Ernst Stratemans, Fly Mario, Geeksmithin, Gia Sierra, George Hart, Greg Tarlin, Ian James, James Sturgeon, Jason Moore, Jeffrey Warren Park, Jason Souza, Jens Larson, Justin Butler, Kyle Eakin, Mega Project Lab, Martin Drake, Matt Filetta, Michael Shepherd, Mike Rapulla, Mike Porter, Ned Dronick, Ollie Johnson, Paul Lopes, Peppy Harmoniemi, Rick Gordon, Robert R. Wells, Sergey, Sid Taylor, Simon Hershey, Spiderman Matt Norman, Stephen Harris, Tate Leswin, Werner Schultz, and William Winstead.